So hello everyone, welcome back to our graph playlist and today's topic is topological sorting. तो ठीक है, तो हमारे पास लेट्स से ये ग्राफ है 0 1 एंड 2 का। तो ये नोड्स है, ऑब्वियस सी बात है, बट ये नोड्स क्या डोनेट कर रहे हैं? नोड्स हमें एक जॉब्स है, राइट? वी हैव जॉब्स और 0 से 1 की तरफ जो एजेस बने हुए हैं, इट इज सेइंग दैट 1 कैन नॉट बी एग्जीक्यूटेड बिफोर 1, बिफोर 0, राइट? अगर 1 को एग्जीक्यूट होना है तो 0 को पहले एग्जीक्यूट होना पड़ेगा, राइट? सिमिलरली 2 को अगर एग्जीक्यूट होना है तो क्योंकि ये एज बना रखा है 0 से 2, तो 0 को पहले एग्जीक्यूट होना पड़ेगा, राइट? So we have jobs, dependencies of the jobs. We have to let's say finish the project such that dependencies are followed, right? हमें उसी वे में इसको एक स्ट्रक्चर बना के एक पाथ बना के जैसे हम बोलते हैं टोपोलॉजिकल सॉर्टिंग, ठीक है? So since 1 and 2 is dependent on the job 0, the first 0 will be executed, and now since 0 has been executed, this 1 and 2 has no relationship or dependency between them, राइट? तो इसे हम एग्जीक्यूट करेंगे, फिर या तो तुम 1 या 2 एग्जीक्यूट कर लो या फिर 2 1 एग्जीक्यूट कर लो, बोथ रिमेन्स द सेम। एंड दैट इज व्हाई कि हर एक पर्टिकुलर ग्राफ के लिए टोपोलॉजिकल सॉर्टिंग के मल्टीपल आंसर्स हो सकते हैं, राइट? Let us see that second example. So let's say we have this 0 2 3 1 3 and 4. So definitely 0 and 1 doesn't have any dependency, right? क्योंकि यहाँ पे कोई भी pointing edges नहीं है towards them, right? तो सबसे पहले जॉब की एग्जीक्यूट है 0 and 1. Since 0 executed, 2 and 3 were dependent on 0 because they have an edge from 0 to 2 and 0 to 3. But since 0 and 1 have already been executed, so 2 और 3 को execute करेंगे हम. Now this order 2 of 3, it can be 3 2 also, right? क्योंकि 2 and 3 have no edges between them, so there is no dependency among them. So now 2 and 3 का ऑर्डर कुछ भी हो सकता है, 2 3 या 3 2, ठीक है? सिमिलरली हमने 1 भी एग्जीक्यूट कर रखा था, तो 1 पे डिपेंडेंट क्या है? 4, राइट? तो 4 भी हो गया। ये जो 2 3 था यार, 2 3 3 जो है 0 और 1 दोनों पे डिपेंडेंट था, राइट? तो हमें मेक श्योर करना होगा कि 0 1 दोनों एग्जीक्यूट हो गया हो, देन ओनली वी कैन एग्जीक्यूट 2 3। बट सिंस वी हैव 0 एंड 1 हैव नो डिपेंडेंसी, तो हमने 0 1 लिखा, 2 3 एंड देन 4। आई होप वी आर क्लियर, राइट? तो सिमिलरली हमें दूसरा इसका सॉर्टिंग क्या हो सकता था कि 0 और 1 एग्जीक्यूट हो गया, तो फिर 2 3 एंड 4 के लिए कोई डिपेंडेंसी बची ही नहीं, तो अब 2 3 4 को किसी ऑर्डर में लिख दो, 3 2 4 या 4 3 2 एनीथिंग, राइट? सिमिलरली 0 और 1 को भी हम किसी ऑर्डर में लिख सकते थे क्योंकि उन दोनों का भी कोई डिपेंडेंसी नहीं था, तो 0 1 लिखो या 1 0 लिखो, ठीक है? तो फिर थर्ड एग्जांपल में आते हैं। तो हियर यू कैन सी दैट द 0 इज आवर फर्स्ट जॉब जहाँ पे कोई डिपेंडेंसी नहीं है, तो फर्स्ट 0 एग्जीक्यूट होगा। 1 0 इज एग्जीक्यूटेड, द जॉब 1 एंड जॉब 2 आर डिपेंडेंट ऑन इट, तो हम फिर इसे एग्जीक्यूट कर देंगे, इधर यू राइट 1 2 और 2 1 एक ही बात है, ठीक है? once 1 and 2 is executed, the another job that is 3 was dependent on it, right? कि अगर 1 और 2 दोनों एग्जीक्यूट हो जाए क्योंकि they have an S to 3, तभी 3 भी एग्जीक्यूट होगा, तो 3 एग्जीक्यूट हो गया, and then once 3 is done, 4 and 5 will be done. So 4 and 5 you can write it 4 5 or 5 4, and that's why it has the multiple answer, ठीक है? सेकेंड पॉइंट क्या है कि टोपोलॉजिकल सॉर्ट इज ओनली वैलिड फॉर असाइक्लिक ग्राफ्स। डायरेक्टेड असाइक्लिक ग्राफ के लिए ये चीज़ वैलिड नहीं है, राइट? एंड दैट इज व्हाई हियर वी हैव अ यूज केस। अगर हमें अगर हमें साइकिल डिटेक्शन करना है किसी डायरेक्टेड असाइक्लिक ग्राफ में, राइट, तो हम ऑब्वियसली चेक कर सकते हैं कि ये साइक्लिक ग्राफ में टोपोलॉजिकल सॉर्ट वैलिड ही नहीं है, वो कोई इसका स्कोप नहीं बनता है, वो भी हम डिस्कस करेंगे। और हम इसे अचीव करने के दो वेज है यार, बीएफएस बेस्ड टेक्निक जिसे हम कांस एल्गो भी बोलते हैं, और एक डीएफएस बेस्ड टेक्निक। बीएफएस बेस्ड टेक्निक इज अ मोर इंट्यूटिव अप्रोच, बट दोनों की कॉम्प्लेक्सिटी सेम होगी, राइट? वी प्लस सी एंड वी प्लस सी, ठीक है? So please pause the video and try to think of approach that how we can, you have been given an input graph like this and we can solve the topological sort. Okay, so that's the pseudo code of the topological sorting, and the idea is that we will keep on printing, the nodes which have the degree as 0, right? 0 and 1 पे कोई dependency नहीं थी क्योंकि they do not have any edges, right? Any up and coming edges to their nodes, and that is why I can say that these jobs will execute first. And simultaneously I can say since there is no edges coming towards them, so that means in degree is 0, right? In degree of that particular node. Okay, so for the better understanding I have written all the in degrees associated with all the jobs here. तो ठीक है, तो इसका ड्राई रन करके देखते हैं यार। So first we have to print the nodes which have in degree as 0. So these two nodes, that is 0 and 1, will have the in degree as 0. So first we will print that, right? So first we will print those nodes and we'll push it in a queue as well. Okay, at this point of time हमारे queue में क्या होगा? That we will have 0 and 1. Then what will happen? The second stage is that we will pull, or we will remove the first node of our queue, and then we will reduce the in degree of all the adjacent node of that particular node. तो 0 को बाहर निकालेंगे और उसके एडजेसेंट नोड क्या है 2 एंड 3, उनका इन डिग्री डिक्रीज कर देंगे, राइट, बाय 1, ईच बाय 1। ठीक है, क्योंकि 2 और 3 की डिपेंडेंसी थी ना इस 0 की वजह से, तो 0 ही हट गया तो ऑब्वियसली 2 की अब डिपेंडेंसी भी खत्म हो जाएगी, राइट। तो हम 1 से उसे डिक्रीज कर देंगे, सिमिलरली 3 को भी 1 से ही डिक्रीज करेंगे, राइट। ठीक है, सो दिस विल बी दी सेकेंड आइट्रेशन, और इस समय हमारे पास क्यू में क्या प्रेजेंट होगा, अगेन वी विल हैव दी 0 को हमने पोल कर दिया तो हमारे पास 1 था, एंड देन व्हाट वी प्रिंटेड आउट, what we printed out, so we printed first of all 0 because we have removed that particular job, और फिर उसके रिमूव करने के बाद उसके नेबर्स में ऐसे कौन से नोड है जिनकी इन डिग्री 0 हो गई। यू कैन सी 0 का नेबर 2 एंड 3 था, विच वी हैव रिड्यूस द इन डिग्री 1 to 0 एंड देन 3 to 2, राइट। ये 3 से 2 बन गया, ठीक है। तो अब इन डिग्री 0 किसकी हुई, 2 की हुई, 2 का हुआ, देन वी हैव टू push it in our queue, right? Similarly, the iterations will follow up. Please try to complete the iteration and then we will see ahead. So let us see the next iteration. Similarly, हमने इस queue में जो elements थे 1 and 2, हमने 1 को बाहर निकाला यहाँ पे, right? And then हमने 1 के जितने भी neighbors हैं उनके in degree को 1 से reduce किया। तो 1 के neighbors क्या थे, 3 and 4, and 3 has the in degree 2, which is now 3 has the in degree 2 यहाँ पे, and now which has been converted decreased by 1, that is 1. Similarly 4 के पास in degree 1 था जो कि decreased हो गया by 1, that becomes 0, right? तो 1 के नेबर्स के इन डिग्री को रिड्यूस करने के कारण उन जिन नेबर्स की इन डिग्री 0 हो गई उनको वापस से क्यू में पुश करो, राइट। तो उनमें से कौन से नेबर्स जिनकी इन डिग्री 0 हुई, दैट वाज जस्ट 4, हमने 4 को वापस से पुश कर दिया। देन वी अगेन पोल आउट फ्रॉम आवर क्यू, and then this time 2 gets out of this queue, and then 0 1 2 would be the here the final output for this iteration। and then 2 का नेबर्स क्या है, देखो 2 के नेबर्स है हमारे पास 3, राइट। that 2 has a directed edge towards 3, तो 3 का इन डिग्री प्रीवियसली क्या था 1, राइट। तो हमने उसको 1 से एक और डिक्रीज किया और वो हो गया 0, ओके। एंड देन सिंस दिस जॉब हैज द इन डिग्री 0 नाउ, तो हमने वापस से उसको क्यू में पुश कर दिया, एंड देन अगेन वी पोल आउट द करंट, we pull out the first node in the queue again, so it would be 0 1 2 4, and then this 4 has no neighbors, as you can see this 4 has no neighbors, has no directed edge from 4 to any other node, so that is why we do not reduce any in degree for that particular neighbors of the 4, क्योंकि neighbor था ही नहीं, राइट। तो ठीक है, फिर हमने वापस में क्यू में सेम काम किया, जो क्यू में एलिमेंट्स कौन से प्रेजेंट है 3, तो हमने उसको वापस से बाहर निकाला, सो 0 1 2 4 and 3, and now the queue is empty and we have stopped here, and you can see that this is our answer, 0 1 2 4 and 3 is our the topological sort for this, one of the answer of the topological sort for this particular graph, right? And what is this time and space complexity? Time complexity is that for each and every vertices uh, uh, we are moving to its neighbors, and then we are decrementing the degree by 1, so it will be v plus e, right? Not v star e, because एक बार उसको process कर दिया तो next time करने की जरूरत नहीं है, so that's why it is v plus e. And what is the space complexity? That we are pushing all each and every vertex in our queue, so it would be o of v, right, as we discussed here. Time complexity is v plus e and space complexity is o of v. Okay, great. So let us move ahead and see the implementation in Java, and then we shall see what the code, how the code is reacting. Okay, so there is a question on the GFG name as the topological sorting. I will mention the link in my DSA sheet. You can access it, whereas you can access the syllabus in this what to say Microsoft Word. तो इन दोनों की लिंक यार डिस्क्रिप्शन में है, आप देख सकते हो। तो ठीक है, देखते हैं। सबसे पहले what was our first step, that we made a queue, and how the graph is given to us. The graph is given to us in the 2D array list, right? How it is given, let us see. So this 1 0 3 and 2, right? So for the 0, yep. Okay, so how it is represented in the 2D array list is, let me show you that first. Okay, so the graph given us to is like this, right? So we have 0 in the middle node, and then 1 2 and 3 is pointing towards it, right? So that means that if we have to complete 0, then we first have to complete the jobs of 1, then 2, and then 3, right? Now this 1 2 and 3 has the degree of 0, so it can be completed in any order, like 1 2 3 3 2 1 2 1 3, that's it. But 0 will be executed only and only if 1 2 and 3 jobs are executed, right? So let us see in the output as well. So you can clearly see the topological order for the graph is 3 2 1 and 0. It can be 1 2 3 0 as well, 2 3 1 0 as well, right? Okay, so how this thing is stored in our ADJ in our 2D array list is that we are getting this index, 1, and then we are adding 0 to it. Similarly, so this is the array list. Array list again, it has the array list, right? So it's a vertical array list, and then for each and every entry we have one more array list in the horizontal direction, right? So 1 we have 0, so for 2 is also we have 0, and the 3 is also have 0. So it just indicates that job 1 can only be done, no, job 0 can only be done once the job 1 is executed, right? Similarly, it has a dependency on 2 and 3 as well. So what's happening is that we are making an in degree array, and then we are iterating in this array list, and for each and every, what to say, hmm, for each and every entry present in the horizontal array list, that is iski index kya hoga, 0, 1 and 2, right? So this 0 has, you can clearly see the 0 has the in degree of 3, right? So that means whatever is present in this, the second part, right, we need to increase the in degree of that particular thing. So that is why we have a for loop here, that first of all we are iterating in the array list, right? And then int x dot adj dot get of I, then we are, for each and every entry there is one more array list, right? So we are using this integer x, we are iterating in that particular list, and we are increasing the in degree. So that means in this particular example we are increasing the in degree of this 0th node, and we have increased it 3 times, right? Okay. So the second step was in the pseudocode that as soon as if the in degree of any node is 0, we have to push it in a queue. We have done that. And then the third step was, but while queue is not empty, we need to keep on removing the first node of the queue, right? And we have to store it in an answer, right? So we have an answer array here of size v, that is the number of vertex, that is the number of nodes in our given graph, and we are storing that particular u, that whenever we remove, store it in our answer. And the second step was that for each and every neighbor, for that particular u, how we can do that, since it's a 2D list, so we will use ad.get of u. That means we are traversing in the array list for the entry u, right? And we are getting all the neighbors, and we are decreasing its in degree. And once you can see, we have done the pre operator here. So we first decrease it, and if after the decrement by 1, if it is at equals to 0, then we again add it in the queue, and this process keeps on repeating, and we have the final answer like that, right? So this is the process we already explained, we already get that part, right? Okay, so that was it. And again, the time complexity is v plus e, and the space complexity again the O of v, because we are using a queue to store all each and every node. Let us compile and run, and we will see, and then we will hit the submit button to verify if all the test cases has been passed successfully. So great, the compilation has been successful. Let us hit the submit button. Also, meanwhile it is submitting, let us analyze the constraint as well, that the time complexity is v plus e, right? The time complexity is v plus e, so we can see the constraint as well. The v is pointing toward 10 power 4, and e is nothing but n star n by 2. So however, if you sum this v and e according to the constraint, it will not exceed 10 power 8, and that is the reason, one more reason, that the code is getting submitted, right? So as you can see, all the test cases have been passed successfully. So this was the standard topological sorting that is done by the BFS technique, also known as the Kahn's algorithm, right? Also known as the Kahn's algorithm. Okay, so let us move back to one variation of this particular question, which is present on the Leetcode, with the problem number as 310, I guess. Okay, course schedule 2. So you can let us read this question, and then we will see that how it is related to a topological sorting. So you are there are total number of courses you have to take, labeled from 0 to num courses minus 1. We are given you are given an array prerequisites, where prerequisites of I represents two values, ai and bi, indicates that you must take course b of I before first if you take a course a. As you can see, here is the dependency. So you can take b of I only if you have taken the course a. That means there is a directed edge from a of I to b of I, right? For example, 0 and 1 indicates that you have to take course 0. um, uh, indicates that to take course 0 you have to take the first core 1. That means this is the first job that is to be executed, so 1 has a directed edge to 0, right? And that is how we need to find if there's any, so return the ordering of the courses you should take to finish all the courses. If there's any valid many valid answer returns any, देखो, so that's why they are saying as well कि यहाँ पे अगर many valid answers present है, कि मैंने बताया topological sort में multiple answers हो सकते हैं. So if it is possible to finish all the courses, else return an empty array, right? ठीक है, तो हम सिंपल सा इसमें यार ये जो प्रीरेक्विजिट्स का यहाँ पे जो 2D array है, हम डेफिनेटली यहाँ पर एक क्या करेंगे, एक array list बनाएंगे. सिमिलरली यहाँ पर इन्होंने प्रीरेक दे रखा था, बट द कोड विच आई जस्ट शोड यू इन द GFG, let us follow that boilerplate and let us make a 2D array, and then the same code will remain same. So how we can make the 2D array here? Okay, so how is the graph made is that 1 and 0, they said that this is the first job that is to be completed, that is 0 has a dependency on 1. So we will have 0, we will have a directed edge to 1. Similarly 0 will have a directed edge to 2. So that means this is like this, the graph is uh, looks like this when we have completed this two cells. So one dependency 1 to 3 is also there, so 1 to 3, and then 1 to 2 is also there, right? So how we can do that? So we just have to connect this cell, right? So 1 to 2 is also done, right? So what is the topological sort for this particular answer? So what's the in degree? Let us define the in degree. In degree here is 0, and then this 1 will have the in degree as 1. Similarly 2 has the in degree as 2 because there is 2 incoming edges, and 3 has the in degree as 1, right? So we have to first print who's the in degree 0, who is the in degree 0. So the job 0 has the in degree 0, so let us print that and reduce the neighbors in degree by 1. So the 2 becomes 1 and the 1 becomes 0 now. So 0, 1 will be printed. Then reduce again the neighbors of this job 1 by 1, right? So 1, the neighbors are 2 and 3, so again decrease it to 1, that becomes 0, and similarly 3 becomes 0, right? So definitely you can write 2 3 or 3 2, right? 0 1 3 2, you can also write it like that, right? So this is your answer, and you can clearly said that these were all the courses. यहाँ पे जो vertex थे, they are denoting the different courses. So definitely if we have a particular topological sort, right, which has, let's say this is an answer array which has the length equals to the number of courses. Number of courses was given, right? So if the length of this answer is equals to number of courses, that means there is a path that there is a path जिसमें हम डिपेंडेंसी फॉलो करके सारे कोर्सेज ले सकते हैं. मैंने जो एग्जांपल समझाया था कि देयर इज अ पाथ कि हम प्रोजेक्ट को कर सकते हैं फॉलोड द डिपेंडेंसीज. यहाँ पे उसी प्रोजेक्ट को इन्होंने एक सब्जेक्ट बना दिया, राइट? ठीक है यार, दैट्स व्हाट इज हैपनिंग. वी आर मेकिंग अ 2D array list, राइट? वी आर मेकिंग द डायरेक्टेड एजेस. हम बस उस array list में स्टोर कर रहे हैं अपनी अंडरस्टैंडिंग से. वी आर नॉट एक्चुअली मेकिंग डायरेक्टेड एजेस, बट हम अपनी अंडरस्टैंडिंग से उसे इस तरह रख रहे हैं 2D array list में, राइट? Again topological sort हमने कॉल किया. We have just passed this graph that is present in this 2D array list, and the code remains same that I just explained you in the GFG, right? The step 1, step 2, and step 3, like I have exactly copied the same code from there. Once we have understood once, then we can just apply it somewhere else as well, right? At last the only variation was कि हमारे पास जो count है, right? हमारे जो topological sort में जो answer आया वो count if not equals to num. Num is what? The number of courses. That means that you are not following that after following the order of topological sort, you are not able to complete all the courses, right? So that means you have to return the 0 empty array as said by the question, else you just have to return that answer, right? Okay, great. So let us hit the submit button here as well. We will verify it and then we'll end this video, and we will discuss that what are all the next question would be that we'll be taking up. So great. As you can see that the solution has been accepted. So let us get back to the syllabus of the graph. So I have directly jumped to this question, but ठीक है, इसे हम वापस से order में कर लेंगे. So once you are done with this topological sort using the Khan's based algorithm, that is the 11th number of question. This 12th number question is very simple. We just have to follow the same code, and you have to see that if the count is not equals to the number of vertices, that means you have a cycle in there. So let me give you a slight one example that why it is not possible for the uh, uh, the cyclic graph, right? So let me take an example for you. Okay, so let us take this example. Let me draw the example and come back to you. Okay, so let us take this example where the cycle exists. As you can clearly see, यहाँ पे ये वाला जो part है, this one, 1 2 and 3 is making a cycle, right? How we can say that there is a cycle? बड़ी simple सी बात है, ये जो edges हैं वो इस direction में होंगे कि cycle बना रहा होगा, right? As you can clearly see, there is a circle making there, right? So that's why I'm saying there is a cycle into 1, 2 and 3, and I have mentioned the in degrees as well. For so 0 it's 0, for the 1 there is 3 edges coming to it, so that's 3, and for 2 there is only 1, so that's 1, and for 3 there is 1 incoming edges, so that's 1 again, and similarly for 4. So for 4 it would be 0, right? However, it is 1, so 0, right? So first what we will do, that we will print the edges, we will print the vertex which has the 0 in degrees, so it would be 0 and 4, right? So let's say we've been processed this 0, and we will decrease the in degree of all its neighbor by 1. So who's the neighbor of 0? The neighbor of 0 is 1. Let's decrease it in degree by 1, so 3 becomes 2, right? Now we will process 4 again. Now we will again remove the we will process which one? 4. So at this point of time it will have 0 and 4. So once we print the 0, right, then the queue will have 4, just 4, right? Because decreasing the neighbor didn't get me any answer of in degrees equals to 0. Now we process the 4, right? We process the 4, and what is the neighbor of 4? That's only, there is one node, that is 1, right? So let's decrease the in degree even, decrement the in degree by 1, and that becomes 1, right? So now there is no node in my queue, that's empty, right? So what to do now? Definitely you cannot, now you do not have any node, कोई भी node नहीं है जिसको मैं pull करके उसके neighbors को check करूँ, right? और यहाँ पे तुम देख सकते हो कि 1, 2 and 3 सारे की in degrees 1 है, तो ये possible ही नहीं है, कैसे होगा इसमें, right? So that is why I said, that is why it said that it is not possible for a cyclic graph, right? Cyclic graph. And that's our second question in our syllabus, that to detect a cycle in which one, in directed graph, right? तो उसमें अगर cycle है तो हमें बस topological sort लगाना है, right? आंसर की जो लेंथ है, if that is equals to the number of nodes in that graph, तो मतलब cycle नहीं है. But if my answer length, as you can clearly see, my answer is just 0 and 4 with length is 2, and 2 is not equals to the number of nodes in this graph, that is 5. So definitely there must be a cycle, वहाँ पे एक cycle था, तभी topological sort जो आंसर नहीं दे पाया, right? So I have just given you, तो हमारे अगले अगला वीडियो जो होगा वो इसी पे होगा, and similarly we will follow this all the questions ahead, right? ठीक है, let us end this video. Till then, keep learning, keep growing. Bye bye, and take care.